Hello, my name is Cindy Lin, and I am a physicist working at SNOLAB and Laurentian University. More specifically, I am a neutrino physicist. Neutrinos are tiny particles that are abundant throughout our universe. In fact, there are 100 trillion of them, and that's a 1 followed by 14 zeros, passing through your body every second. But you don't feel or detect them because they are so small and they don't like to interact very much. And we know that neutrinos can come from many different sources. These sources can include the sun inside of our Earth, nuclear reactors, or the explosion of stars, or supernova. By studying neutrinos, we can learn so much about the science that's happening inside of our sun and our Earth without digging very deep or flying into a fireball. We can deduce the output that comes from a nuclear reactor. We can even know when a supernova is about to happen hours before the visible light reaches our Earth. So how do we detect something that doesn't want to be detected? Well, one of the experiments doing this is called SNOW+, which is what I work on. So SNOW+ is located in SNOLAB, which is 2 kilometers underground in Lively, Ontario. Imagine the length of 34 standard hockey ice rinks, and now take that and flip it vertically, and that's how deep SNOLAB is from the surface. The detector itself is a 12-meter sphere with a neck. And to give you an idea of the scale of this, 12 meters is about 8 of an average height 6th grader. And so when a particle comes in and hit the oil that's inside of our detector, it will leave some energy and create light. This light is then picked up by our photomultiplier tubes, or PMTs, or a very expensive and sensitive camera. And different particles have different shapes and energy signatures in our detector. So here we see each of these hexagons is a PMT, and shown here in this ring is a signature of a neutrino from our atmosphere. So sometimes my work requires me to take an elevator and go 2 kilometers underground to take care or maintain our detector. Other times I work on surface doing computer programming, trying to make sense of all the signals we get from our detector. And as much as that we have learned about neutrinos since 1940s, there are still so much we don't know. For example, how much do neutrinos weigh? Or why are they so much smaller than all the other particles? Are neutrino and its antimatter the same thing? If they are, is that why we have more matter than antimatter in our universe? Is this why we exist? These mysteries about these tiny particles that are everywhere in our universe keep them very interesting and can potentially answer a lot of big questions for us. Thank you.